Hello, welcome to Unit 7, Probability with Combinations and Permutations. Learning target, I can solve probability problems involving combinations and permutations. These are awesome problems because it's all of our probability stuff in one, hence why it's like 6 or 8 points on your next quiz. So make sure you understand the difference between them. So let's review a little bit. So if I'm reviewing, we have combinations. So that is NCR, bunch of confusing things. Most importantly, note you subtract it and then divide by R factorial again. So whatever that number is, you have to use it twice. Now remember, order is not important. No importante. Alright? And these are going to be your cards, your groups, teams. Need 5 on a team. Order does not matter. Committees. Alright? So make sure you're paying attention to that. Then our other one is permutation. So then the order does matter. And it's got a bunch of things like place. You know, first, second, third, gold, silver, they're different. So that placing of stuff. Different jobs. So if you got a secretary and a treasurer, those are different jobs that you can be applied to. So those are order matters. Also, like a pitcher lineup, a batting order. We're getting too sports specific. Don't write batting order down. We don't ever actually use that. I was just thinking out loud. Alright, moving on. A combination bike lock requires a 3-digit code made up of digits 0 through 9. No number can be used more than once. Well, I would love to know, always find the total number of ways first. This will be the bottom of your probability fraction. Boom. That is actually this thing right here. How many different combinations are possible? Well, since we just talked about it, yes, this is going to be a permutation, right? Order matters with numbers. So now, if this is a permutation, how many ways is it possible? How many different combinations? Well, we have 10 numbers, and we need to have 3 of them in a specific order. So then I come over here. We're really getting good at this. We'd have 10 factorial over 7 factorial. Now, how did I get that? Remember, it is n over n minus r. So 10 minus 3 is the 7. When you do that, I usually write it as 10 times 9 times 8 times 7 factorial, all divided by 7 factorial, so everybody would know that these cancel out. So 10 times 9 times 8, this one is going to equal 720 ways in which that can happen. So we calculated this nice permutation, and we got 720 ways. Remember, this is step 8 because that little note that's crooked there tells you it's step A because you have to start with the 720. So what are the probability that all the digits of the code are odd? Well, we need to do a couple things. And first, we're going to know that the odds are 1, 3, 5, 7, 9. Turns out there's 5 odds. So what's the probability that all of them there? Well, we can only choose from 5 out of our possible 10, but we need to choose 3 still. So then what I would suggest is I just always write the 5 over that. 5 minus 3 is going to be 2. So over here, I'm going to have 5 times 4 times 3, and the 2's cancel. So 5 times 4 times 3 is 60 ways. So if you stop here, you're going to get a point off on your quiz. It says, what is the probability? Well, probability, I'm good at that. If I know the probability of odds is going to be the total number of ways, which is 60 ways of doing odds, out of the possible 720 ways. So when I do that, this is approximately equal to 0.083. So the probability of odds, all odds, is 0.083. So remember, you got to read the questions a little bit and figure out what's going on. Don't forget our 720 number, because that's our total. Because now, when I go up here, I gotta move D down, but let's do C first. C. What is the probability that first digit is a 3? This one isn't too bad because I need a 3 first. How many 3s are there? There's 1. Well, this can be any number. This could be any number as well. Right? So all I'm worried about that there is a 3 first. So then what I do is there's a possibility. What is the probability that the first digit is 9? So there's 9 numbers left. Now on the top it says no number can be used more than once. So I've already used the number for the second spot. So 1 less than 9 is 8 remain for the last spot. So then 1 times 9 times 8. Right? That's what these ones were supposed to be, was multiplication times. They're grouped together. I don't care anymore. 1 times 9 times 8 is going to equal 72 ways. So there's 72 options that a 3 could be first. Well, if I divide that by our 720 total outcomes, I would have the probability of a 3 for the first digit, FD first digit, would be equal to 0.1. Right? And that makes sense. Right? There's 0.1 chance of picking a 3. It's 1 out of 10, 0.1. So the probability that it's a first, it makes sense. So then our last one, last but not least, D. What is the probability that the code is 123? So we need a 1 first, a 2 second, and a 3. Well, what is the way that there's a 1? A 1, a 2, and a 3. There's only one way that each of those numbers can be the code. So out of the 720 ways that we can make that code, we pick 1, 2, 3. So that is one way we could have done it, is a 1, a 2, and a 3. 1 times 1 times 1 is 1. Out of a possible 720 combinations, and that is going to equal, well, I didn't write it down for some reason. 1 divided by 720 is an awesome value of approximately 0.0014, right? Probability that the code is 1, 2, 3. So a lot of these P's is the probability of 1, 2, 3. So the probability of odds was right here. I'm circling it right now. Underlining. Probability of odds. That's how they're going to usually write that. A capital P on the outside tells you that's the probability of odds, and it's 0.0 approximately equal to 0.083. So that's a lot of work, which is why this is so many points. So remember, this one in C is just probability that it's a 3. It's 1 out of 3. Then we go to this any. Well, how many numbers are left? If I take 1 away, out of the 10, there's only 9. So that's not a permutation. That is just a probability that the first digit is a 3, right? That is not a permutation. So let's look at some other things that aren't permutations. So a word processing program requires a 7-digit registration code made up of the digits 1, 2, 4, 5, 6, 7, 9. So this is going to be important because these are the only group of numbers that we could use. No number used more than once, so we have to be paying attention. So since we are using all of them every time, we don't have a permutation here either. Right? What I'm looking at is how many different registration codes are possible. Well, since we have to use all of them, we're not picking 3 from the 7, we're using all 7. So what that actually becomes is a permutation of 7. Now, if you would have picked 7P7, you would have had 7 minus 7, and it would have been 0. So even if you're not sure, 0 factorial is always 1, is what they say in the book. So 7 factorial is what you're going to end up with. And if you multiply that together, there's going to be 5,040 codes that we could use. So if you would have had divide by 0, if you get a divide by 0 one, you might have it right still when you're calculating how many different registration codes are possible, as long as you are using every number. So then B, what is the probability that the first 3 digits of the codes are even? So if I come up here, 2 is an even number, 4 is an even number, 6 is an even number. So actually, if I look at the evens, so I need an even, and an even, that actually leaves all the odds left. So O for odds. Right? Well, how many evens were there to choose from to be first? Well, there are 3 choices for the first even. Alright? Now, it doesn't matter if I pick the 2, the 4, or the 6. If I use one of them, there's only 2 left to choose from, and then a 1. So it happens that all 3 digits, or all 3 evens, are used up right away. Now, the 1, 5, and 7, and 9 are available. That's 4 combinations. So there's 4 choices for my first odd. Then there's going to be only 3 for my second odd. Then 2, then 1. So as I used up all the evens, then I used up all the odds because we're using every number. 3 times 2 is 6. Right? Times 1 is still 6. Times 4 is 24. Times 3 is 72. Times 2 is 144. Times 1 is 144 codes. Out of a possible 5,040. So this is like the most important number every time when it says how many are possible. Have to do that because the probability here in B is going to be approximately equal to 0.029. So this is probability that the first 3 are even. So we need that 5,040 number. Ooh, perfect. I might try to fit all this on here. So C, what is the probability that first digit is 1? So this goes back to me going, all right, the first one's a 1. Easy enough, right? And then after that, it can be any of the choices. So we just got to use them all up. Any, A for any. I don't even know what I sound like right now, but it's all right. So any combination I want to pick. 1, 2, 3, 4, 5, 6, 7. All right, so I got them all in there. So if I have to use the 1, there's only one number I can choose, and that's the 1. That's why it's a 1 there. Now, if I'm choosing any letter or any number that I can, there's only 6 remaining letters. And then after I use the 1, then there's 5. Then there's 4. Then there's 3 times 2 times 1. So I'd probably look at this, and I go, all right, so you're just doing, this is going to equal 6 factorial. So I'd probably type 6 factorial on my calculator. It's going to give me 720. I divide it by the 5,040, and probability that a 1 is first is 0.143. So that's not too bad either. All right, let's see how much room I'm going to need for D. What is the probability that the code is 1, 2, 4, 5, 6, 7, 9? These are actually my favorite ones because what is the probability that it is exactly that code? Well, there's only one code that's written like that, and guess what? It's chosen out of 5,040. So there's a lot of different combinations that it could be. It'd be 0.002. So that's a pretty small number. So if it's an exact thing, it has to be a 1 first. Well, look at that. If it has to be a 1 first, we can just know that there's only one choice. It has to be this number. Well, that's only one way that number can be first, or that it has to be that. So you have to kind of use some senses. We're not doing permutation and combinations every time. It looks like we're just doing permutations and combinations for our total number of ways possible. So a group of 7 seniors, 5 juniors, 4 sophomores have volunteered to peer tutor. Mr. Dominguez needs to choose 12 students out of the group. Mr. Dominguez looks like a smart guy. So when I look at that, we need 12 students. All right, well, I got to figure out if I'm using all of them up. So I got 7 seniors and 5 juniors. So I'm at 12 already, and then 4 sophomores have volunteered. So there's actually a total of 16 candidates for 12 positions. And now I say it like that because I want you to understand, if I pull this guy's face over here, how many of the ways can the 12 students be chosen? It is actually 16 choose 12, right? We're not worried so much about if I'm the first one chosen, I don't get to tutor somewhere special, all right? I am just a tutor. So 16 choose 12. I would say I got 16. Now remember, with combinations, you do 16 minus the 12, and then the 12 again. So if you've been watching my videos, I usually write 16 times 15 times 14 times 13 times 12 factorial, all over 4 factorial, 12 factorial. So what I would probably do is I would probably get rid of these 12s. Right? When you do this, and I'm going to challenge you to do it on your own, you're supposed to get 1,820 ways for that to happen. So these are the total number of ways. That's our important one that we need to use again. So then it comes in here. What is the probability that he chooses 4 seniors, 4 juniors, 4 sophomores? So 4 of each one. All right, I'm already going to extend the page out. I forgot to do something. If you are looking at your paper, it says on the top, a group of 7 seniors. So what you need to look at is 7 seniors are getting chosen, or 4 seniors are getting chosen out of 7. Right? Then there's going to be 6 possible juniors for just 4. And then 4 choose 4. Now what we actually do with those is those are probabilities that we need to multiply together. Right? The probability of a probability of a probability, you're going to multiply them together, see how many ways you get. All right, so how many ways is this possible? So I probably would write this, 7, choose 3, 4. All right, 7 minus 4 is 3, that's how I get the first one, then the 4. Then 6, oh, I screwed up, it's not 6. There's only 5 juniors. So 5 minus 4, I would have wrote 1, and then it's going to be 4 still. And then 4 choose 4, so this is that 4 factorial, all over 4 minus 4 is 0 over 4. So if I challenge you to find these again, on your own, right, you should have got 35 times 5 times 1. When you do that, if you can find those on your own, you're going to get 175 ways that it's possible to pick 4 seniors, 4 juniors, and 4 sophomores. Now this is ways, remember. So when I go up here, I need to do 175 divided by 1820. Because that is going to be the number of ways that this can happen. The probability would be 0.096 for the probability that he can choose 4 seniors, 4 juniors, and 4 sophomores. Now the next thing would be, and I'll pull it over here, what is the probability that all 7 seniors are chosen? So I look at that. Our 1820s number is right here, so we got to use that to calculate probability. Now it says all 7 seniors are chosen. Now remember, there was 7, choose 7 then. We're choosing only the seniors. Alright? And if you look at something, when it's 4 choose 4, it ended up being a 1. So this is going to be a 1. So we choose all the seniors. Then the next best question is, out of the total of 16 people, we now know that there's 9 left for, there is a total of 12 spots being open, so the rest of the 9 have to fight for 5 spots. So what we would do is this, I'll do this one with us. We do 9 choose 5. So we'll have 9 over here, over 4 factorial, 5 factorial. 9 minus 5 is 4, so I get the first one, then it's 5 again. Now if I did that, I do 9 times 8 times 7 times 6 all over 4 times 3 times 2 times 1. Really good at getting rid of the 5 and erasing all that. 4 times 2 is 8, so I'd probably get rid of this 8. 3 divided by 6 is 2. 9 times 7 times 2 is 126 ways. Now what I actually have to do is take that 126 and I have to multiply it by the 1 way from this, from choosing all the 7 seniors. In this particular problem, it's just 126 ways. On your test, it's a bunch of big numbers that you have to multiply together. Right? So 126 ways. So I do 126, and we are dividing by 1820 in this particular problem to find our probability, and our probability is 0.069. So don't forget, you're finding the number of ways. Right? You're still dividing by this. So somewhere you need to put this in my mind. All right. Hupert said that when we do this, we are multiplying these things together. If they're different combinations, you multiply them together. Because that's how you get the total number of ways that all those probabilities can happen. All right, last one. 4 more steps and we're done. Diane has a bag full of coins. 10 pennies, 6 nickels, 4 dimes, and 2 quarters. I've done some math ahead of time. There are 22 total. So what's that mean to me? How many ways can Diana pull 4 coins out of the bag? So I look at this one, Diane. I said Diana before. Diane pulls 4 coins out of the bag. That is going to be 22, choose 4. Doesn't say she needs to pick anything special. So when we do that, you're going to have 22 times 21 times 20 times 19. 22 minus 4 is 18 factorial, so I know all those are going to cancel out, leaving me with the 4 times 3 times 2 times 1. You need to be able to get 7,315 ways. And to be honest with you, your test ones are in the tens of thousands, so get used to dealing with big numbers. Now once we go from that, let's see what next question is. What is the probability that she will pull 2 pennies and 2 nickels? So 2 pennies. So I see 10 possible pennies, and she needs to get 2 of them. Now, it doesn't matter which penny she picks, or if she picks a penny first or a nickel first. So I'm going to go combination again. Then I got to figure out how many nickels are out there. So 6, choose 2. Right? Now, last problem was the thing. We got to do the count, weigh how many ways for the pennies, how many ways for the nickel, and you multiply them together. It's an in statement. So it told you on the first test, a lot of in statements are multiply. So, 10 choose 2. If you can do this in a calculator, you're going to get 45. 6 choose 2. You're going to get 15. So if I do 45 times 15, I'm going to get a grand total of 675 ways. Now, what do I do with that number? I still divide it by the total number that things that can happen. I get a probability of 0.092 for this probability. So notice A is always going to ask you how many number of ways can something happen. Then we start doing some probability stuff. So don't lose 7,315. Perfect. C, what is the probability that she will pull her 4 pennies out of the bag? Well, good news. I only have to do one thing. I'm only worried about the pennies. So I need 4 pennies. There's only a total of 10. So 10 choose 4 is actually going to be 210. Alright, so 210 ways out of 7,315 ways. And that is going to equal 0.029. So what I'm looking at is, hey, the only thing it's asking about is pennies in green here. When it only asks about one thing, I only have one combination or one thing to solve for. All the pennies. So out of 10, you pick 4. Well, then I just have to do my division at the end of one thing instead of multiplying those together. So very similar here. Dimes. Out of the bag, she will pull her full dimes. So you're only worried about the dimes. So I know that there is only 4 dimes in the bag. 4 choose 4. And we've been over this. This is going to be 1. You're dividing by 0 factorial. There's a 1 on the bottom, blah, 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 blah. So then 1 out of 7,315 is going to equal 0.0001. These are all approximates. I'm a bad math teacher. Don't tell anybody. So, always look for the total number of ways. And then find the ways that certain things can happen, and you divide the sum ways by the total, and you have a result of probability. Alright, thank you for listening. Hopefully probability was fun. This was the last notes video for that. Have a great